Hello, I am Aaron, and welcome to my HackSoc talk, The History of Calculators. So we'll start off with possibly the most obvious question on the subject of this talk, which is, well, why calculators? Why am I so interested in those specifically? Um, I first got my first scientific calculator in about high school, then moved on to a more advanced one a couple of years later. And then a little bit after that, I got a graphing calculator, and that was what really hooked me. I was fascinated by this handheld device that I was allowed in both the classroom and in exams, that I could do everything that I'd been sort of doing on pen and paper. It could just do automatically, and that really fascinated me. As a more general sense, I think early calculators are pretty important milestones in the history of computing. I think they showcase really well the sort of time periods where different technologies came in. For example, when things moved to transistor technology and when computing began to sort of shrunk to like pocket size. I also think in more modern calculators it's interesting to look at how different manufacturers approach different things, even though they're all aiming towards the same goal, which is to help you to do mathematics. In the same sense, it's interesting to compare Android and iOS. I think it's interesting to compare how different manufacturers approach helping you solve different problems. And also, in a more computer science sense, I think that calculators are actually really good programming platforms. I got my introduction to C by programming for my first Casio graphing calculator. I made little games and apps and stuff. And some of the community creations, we'll see a couple later on, are seriously impressive, really, really impressive things. I also thought I'd best mention I'm currently working on my own graphing calculator, which is the Delta Pico, just as a little hobby project. I'll pop a link in the description, but it's a little graphing calculator based on the Raspberry Pi Pico. So while I've been developing that, I've been looking at what modern calculators exist and sort of comparing their feature sets to see how I should design mine. So it goes without saying that there have been a lot of calculators in history, and unfortunately in about half an hour we can't really cover all of them. So I'm going to split this talk up into 4 rough sections, and then we'll skip between those sections of history as we go. We'll start off with mechanical calculation. So let's start with the really early days, before anything even like the modern calculator even existed. Before we had calculating machines, we had calculating tools, where humans still had to know how to use them effectively, but they could still help you with calculations. The most notable of these is the abacus, which is ancient history, but still, readily available today. These essentially consist of a frame with moving beads, but around the world there were some impressive variations of these that look quite a bit different from the abacus that we might be used to. There was also a slightly more primitive version of this called the counting table, which was a bit more freeform, rather than having a frame with beads that would move into particular areas of the frame. You would just have a table with marked areas where you could move the beads around. But it was the same kind of idea. And with the right methods, with any of these abacuses, you can do addition, multiplication, subtraction, division. They're very capable when you know how to use them. In about the 17th century, something similar but a lot more advanced came along, which was the slide rule. These were sort of before pocket calculators were something that you could really have and used, which meant that they were still used well into the 20th century, about the 1960s, 70s. These didn't do addition and subtraction, but they did do multiplication and division, and they did that by using the laws of logarithms. So you had 2 scales that could move along each other, and you could use that to perform various different calculations using logarithms really quickly. There were also more advanced slide rules that might have different feature sets and different additions. So for example, things like trigonometry you could also do on your slide rule. And in the sort of fields of science and engineering, these were a really common tool to have. They were very convenient. You just slip them in your pocket, and also relatively cheap. But let's start looking at actual calculators now, where you still have to know how to use them, but they can do the calculations mechanically for you. There were quite a lot of experimental mechanical calculators before this particular one, the Arithmometer. But they were sort of like, produced in very small quantities and tended to just sort of be invented by a sort of single person. But the timing of the arithmometer in 1851 meant that it fell right in the Industrial Revolution, which meant that it was the first calculator to become a commercial success. These could do addition, subtraction, multiplication, and division. And compared to what we have nowadays, the input system is relatively primitive. You would select your number using a slider, so you would slide between 0 and 9 for each column. And then to perform the operation that you were doing, you had to turn a crank handle, and you would watch the result be populated on some little dials through some peepholes in front of you. So as much as it might sound rather primitive, this was, a really important milestone. You could buy a mechanical calculator for your office or wherever and use it there. There were quite a few evolutions on top of this, but I think one of the most notable ones, and one that we'll look at, is the Comptometer. So this aimed to perform, a similar goal, but as you can see in the image, it looks a fair bit different, and we'll come on to why that is very shortly. These were invented a bit after the arithmometer in 1887, but they were still manufactured well into the 1960s, and that was because you could be extremely efficient with these, and we'll see how very soon. When they were originally produced, they were fully mechanical, but over their very long lifespan, they gradually transitioned into being electrical models. So, as you can see, this unique keypad, it's called a key-driven design, where as soon as you press a key, some operation occurs. There's no kind of buffering. Like on a current calculator, you might type 1, 2, 3 and then press enter, and that would submit the number 123. Whereas on this, if you press a button in one of these columns, it will apply immediately, and we'll see what that means in just a second. This has actually turned out to be really powerful. There was a bit more of a learning curve, but how to use these was taught as a skill. And when you got familiar, almost kind of like touch typing, you could become extremely fast at doing calculations on these. And that's why it has all of these columns. So what I'm going to cut to show you how these work is a little demonstration that I will do of how this actually works. And then we will come back here and carry on through history. Let's take a look at a comptometer. So, I'm running this on a web-based simulator because I do not, unfortunately, have access to one of the real things, and I'm also running it on a tablet because I want to be able to press multiple buttons at the same time, and with a mouse you wouldn't be able to do that. What are all of these many buttons then? Well, the columns you can think of as number places. So the first column is the ones, then the tens, then the hundreds, then the thousands, and so on. Going up each of these columns are the digits 1 to 9. There's no 0, and the reason for that should become clear quite soon. So let's actually use this. How do we use this? Well, in its normal state it works like an adding machine. So the result is currently 0, shown along the bottom there. So if I want to add 5 onto that, I can just tap 5 in the ones column, and it'll add 5. If I want to add a further 7 onto that, I can press the 7 in the ones column, and we get 12. If I want to add 60 to that, I can press the 6 in the tens column, and I get 72. So it keeps adding onto the result that's already there. If I want to clear that, I can pull this handle. The reason you don't need a 0 is because adding 0 would have no effect, so there's no need for a 0 row. Now, how is this beneficial? Well, if we want to enter a number with multiple digits, then we could press them in turn. So we could, for 247, we could press the 2 in the hundreds, 4 in the tens, and 7 in the ones. Or we could press them all at the same time. So if I clear this, we could position our fingers so that we press all 3 digits at the same time. And with tactile buttons, this would be a lot easier, and it allows you to sort of feel your way around. And in actual fact, these were often taught so that you could use them like touch typing, where you wouldn't have to look at the keys, you just know where they were and be able to press them. As another way of accelerating your speed using these, a lot of them came without any numbers above 5. And to enter the higher numbers, you would simply press 2 of the lower numbers at the same time together. So rather than entering 9 by moving your finger all the way up to 9, you just press 5 and 4 in the same column and get a 9. So I hope you can see how much faster these are if you get used to them. You can enter entire numbers simply by pressing loads of digits at the same time with one set of keystrokes, if you like. For adding up large sets of numbers, these can be really quick. Now you can also use these for subtraction. I'll pop a link to this simulator in the description and let you have a play around and see if you can figure out how the subtraction works. You can also use them for multiplication and division, solely because multiplication is just repeated adding and division is just repeated subtraction. Okay, let's get back to the talk. So that was a look at the Comptometer, and I'm sure you can see from that that they are really useful tools, and when you got proficient at them you could do calculations incredibly quickly. But towards the end of the Comptometer's life we started seeing electrical calculators come about, so let's move on to talking about those. So the first all-electrical calculator was the Casio Model 14A, which worked off relay technology. And as you can see from the picture, it is absolutely massive. It was built into a desk. It's not just a desktop model, it was built into the desk itself. It used a 10-digit keypad rather than a Comptometer style one. And it had a rather primitive sort of display technology where rather than having a sort of individual display for each column, it had an individual display for each digit of each column. So it was a grid with 0, 1, 2, blah, blah, 9 for each sort of column of the number, and it would light up the corresponding digit. But it worked for its time. Only a few years later, in 1961, we saw the first electronic calculator, which is the Symbolic Calculations, standing for a new inspiration in arithmetic, or in accounting, depending on where you looked. This was the Mark 7 calculator, because Mark 6 and before had all been the same brand's mechanical calculators. So this used vacuum tubes internally, which is another sort of more primitive digital technology. And it also used Nixie tubes for its display, which I think look absolutely lovely. This went with a Comptometer style input mechanism, and unlike the Casio, could fit on a desktop rather than being the desk. So that was a nice little reduction in size there. But I think another milestone is when calculators have transitioned to transistors. Because transistors are largely how modern technology works, although they're pretty squished into integrated circuits rather than being sort of discrete logic elements. So the Friden EC130 is at least a contender in 1963 for the first transistor logic calculator. There are a few others that came about very, very close, including a model by Sharp and a model by IME. But this seems to be the most commonly held one as the first one. This used a gorgeous CRT display, and you can see the massive cathode ray tube in the sort of open diagram there. And this also used something called reverse Polish notation for its input, and that was why it needed a relatively high resolution CRT screen. And we'll come on to what reverse Polish notation is in a little bit. Another important milestone for calculators was the ability to program them. The first programmable calculator was the brilliantly named Mathatronics Mathatron 424 in 1964. And then it had a mode called Learn, which was its programming mode. But you could also get it pre-configured with some programs stored in its ROM. So for example, you could get models that were pre-configured with hard-coded programs for things to help with civil engineering or statistics and things like that. But just a year later, the Olivetti Programmer 101 came along with a much wider set of programming features. So this time you had conditional branching, unconditional branching, so you could sort of hop around your program, And you could store your programs on magnetic sort of storage cards. So the much more advanced features of this calculator made it a fair bit more popular than the Mathotronics model. But around this sort of time, it raises an interesting question of what's a programmable calculator and what's a computer. I'll let you sort of make your own decisions on that. And as one of the sort of final milestones of the early days of electrical calculation, we've got portable calculators. The Caltech was a prototype from 1967, which takes the crown of being the first handheld calculator, but it wasn't actually on the market at this time. By the time it reached the market in 1970, it had a bit of competition, and it was also renamed to the Canon Pocketronic. It had some competition from Sanyo and Sharp. As a little tidbit, this Caltech prototype was actually auctioned off in 2020 for a few tens of thousands of dollars. Sinclair also made some interesting innovations with handheld calculators because they managed to make them extremely cheap, whereas these early handheld models were relatively expensive at the time. And then just a year after that, the advancement of technology really picking up at this point, a company called Mostech released the MK6010, which was a calculator on a chip. It was a dedicated chip, integrated circuit, designed to, provide the functions of a calculator. So you could just plop this chip somewhere, wire it up to a display in a button matrix, and then you would have a calculator. I think the way that we went from the earliest prototype of a portable calculator to a chip that does it all in just 4 years, I think it is really remarkable. So we've covered the early electrical calculators now, and they only really advanced from there. They got cheaper, they got more compact, and more capable. But there are a few particular innovations that I think are really important, so I'm going to go over what those are now. So one of these innovations that I think is really important is reverse Polish notation, or RPN. HP introduced the 9100A, which was the first desktop scientific calculator. This wasn't the first calculator to use RPN, but I think HP is a good company to look at here because they are sort of known for continuing to make RPN calculators to this day. This first scientific calculator had features like trigonometric functions, you could also do logarithms on it and things like that. And then they adapted this, shrunk it down into HP's first ever handheld model, which was the HP 35, only 4 years later in 1972. So both of these calculators use this RPN input. So what is RPN exactly? Well, in traditional calculation sort of layout, in infix mathematical layout as it's called, or algebraic layout sometimes, you have the operator in the middle of its two operands. So you write 2 plus 3. But the problem with this is that your operators need to have some kind of precedence. So, we need to know that 2 plus 3 times 5, the 3 times 5 bit would come first, but you can override this using parentheses. RPN calculators take a different approach, where rather than using infix notation, they'll use postfix notation. So you would write 2, 3 plus 5 times. Rather than having to add those parentheses, you've expressed the order of operations with just the order that the operations are coming in. It's always read from left to right, and it works like a stack. So when you read the 2, it puts a 2 onto the stack. Then you read 3, puts 3 onto the stack. Then you encounter that plus operation, which will take the 2 items off the stack, combine them together, get the result of 5, and leave that on the stack. And you encounter another 5 in the input stream, put that on the stack. Then you encounter the multiply operation, so you take the 2 items off the stack and multiply them together. So this is preferred by some people. For example, it doesn't need parentheses, so you can't sort of get lost in how many levels of parentheses you're in while you're inputting a really long expression. And some people just prefer it because when you become proficient in it, it can be quite a lot faster. And RPN has gained quite a sort of following. HP still produce RPN calculators, and some people just love that over infix, and I can certainly see the advantages. Um, Another key innovation was graphing calculators. I mean, this is how I got interested in calculators after all. The Casio FX 7000G, of which I have one right here, was the first graphing calculator. It came out in 1985. It had an LCD dot matrix screen, which was pretty big for its time because it needed to be able to, show the graphics. Um, it wasn't it wasn't on its own for long. HP and TI both followed up with their own graphing models pretty quick after, 1986 and 1990 respectively. I think this was a really important time for calculators because it created an entirely new class of calculator. Before this, you might have had sort of standard calculators, then maybe sort of, financial ones, and then scientific calculators. But graphing came along and created an entirely new sort of highest tier of calculator, and it remains that way to this day. The graphing calculators are always the sort of more premium options. And the final innovation that we're going to look at here is symbolic calculation. So this is where you might involve algebraic unknowns, like your x variable, in your calculations. The Casio FX 5500 in 1986 was the first to be able to do this. It was in a rather limited form, but it could still do it. It could simplify expressions, so if you had x plus x, it can give you 2x. It could expand algebraic expressions and also do some basic solving, but there were limits on how much it could actually solve. The HP28C came only a year later, and this is pretty widely regarded as the first proper symbolic calculator, with a computer algebra system, or CAS as it's abbreviated to. It was a lot more capable. You could isolate variables, as this calculator called it, so you could rearrange an expression in terms of another one. You could differentiate and integrate with your algebraic expressions too. And the solving was a bit more fully featured, and you could also do factorization and things like that. It's worth noting that before these calculators came around, there were pieces of computer software that could do this kind of algebraic manipulation, but having it in a portable calculator was quite an innovation. And finally, we'll take a look at the modern day. What's the state of the calculator now? So first of all, I'll look at the UK, which is, where I had my education. And if you were educated in the UK, like I was, you have probably seen a lot of these. The Casio FX83 GT Plus. And I think this calculator really shows how far they've been able to come since their innovation. I mean, I know it sounds obvious, but the first handheld calculators were really expensive. You could only do this sort of 4 key operations. Might have had some sort of primitive display mechanism. Whereas here, now, you can walk to your local WH Smith's and buy a scientific calculator with a dot matrix display for £10. With a really advanced feature set. This one has a natural display system, so it can show expressions vertically as well as horizontally and notate them really nicely for you, so they look like how you'd write them on paper. I feel like this is a really sort of important stage in calculators where you can go out and buy something really capable for so cheap. Although interestingly, technology still marches on, and this is actually being replaced by a newer model now with a much higher resolution display, a new ClassWiz model, as Casio's branding is calling it. But what about in the US? Well, here we have Casio, but in the US it's pretty much all Texas Instruments. And TI have a pretty long and very iconic range of graphing calculators. The TI-84 Plus is probably the most iconic graphing calculator that there is. It's extremely common in sort of the American education system. Full graphing capability. It's relatively old inside technology wise, but for a calculator, it's still perfectly capable. Um, there are also some other models around this one. The TI-83 is a slightly more cut back version, and the newer TI-84 Plus CE models have full colour displays and a much more modern design. Now, TI being by far the sort of biggest manufacturer in a very large place means that there is one very iconic thing, I think, about these calculators, which is the scene for development. The TI-84 family have an incredible amount of development behind them. There are very impressive applications and games for these. There's a Game Boy emulator, which I just think is incredible, and there's loads more sort of homebrew games as well. So if you're bored in your maths class, got plenty of choice. And there's also premium options, just like with any technology now. You can buy, a budget phone or a high-end phone. You can buy a low-end calculator or a really expensive calculator. Most of the manufacturers have one high-end option. Here we've got the HP Prime, which has a touchscreen, and the Casio ClassPad, which also has a very large portrait sort of smartphone-looking touchscreen. The TI Nspire doesn't have a touchscreen, it does have a trackpad, and also at the bottom there it has a full letter keyboard. And in this sort of premium space, there have actually been some new brands come around as well for more enthusiast level calculators. One of the newest ones, which I absolutely love, is the Numworks. So this is a sort of independent calculator brand who only make one model, but it's very fully featured, colour screen, Python programming, which is an increasing trend on modern calculators, which I'm really glad to see. And also Swiss Micros, which is a kind of artisan calculator brand, if you like. They essentially make really high-end models of the older HP RPN calculators with gorgeous memory LCD screens and really sort of high-end build quality. Quite a lot of these premium options contain a CAS, the computer algebra system that we looked at earlier for sort of symbolic manipulation. So some of these aren't actually allowed in exams. They're just, they're just, I think, lovely devices that really show off how powerful these calculators have come to be. But there's another thing about these premium options which you might not immediately think of, which is that just like any other piece of technology like a phone, there are ecosystems around these calculators. We'll look at one of them in particular, the TI Nspire's ecosystem, but they all have some level of ecosystem really from all of the big brands. So if you've got a TI Nspire, you can stick a little yellow hat on it, and it has wireless networking, proprietary wireless networking. So that allows it to connect to a teacher's computer, and then if an entire classroom has TI Nspires, they can push out some kind of exercise to all of the calculators in the room at once. The Nspire uses a document system, so they could push out a document containing a quiz or something to everybody's calculators. If you're in a science lab rather than a maths class, you can connect the lab cradle, which will let you plug in sensors to your calculator and use it for things like data collection. It supports a massive range of sensors like temperature, speed, all that kind of stuff. And then one of my absolute favourites is that for your TI Nspire and your lab cradle, you can buy the Veneer projectile launcher. You connect this to your calculator and you can control the speed at which a ball will launch out of a launcher to do experiments with things like trajectory. I just love the way that you can get something for your calculator which calls itself a projectile launcher. But anyway, final thing that we have to talk about in the modern day is modern technology. What else is out there other than calculators? Because there's a lot of ways to do a calculation nowadays. You don't have to grab a calculator. You've got a phone, you've got a computer. In a lot of contexts where you'd actually want to do a calculation, the software can just do it for you. For example, if you've got a spreadsheet, you need to sum up some totals, you can just pop a formula in or use AutoSum or something like that. It'll handle it all for you. You don't need to sort of switch to a dedicated calculator. And if you need more advanced features, services like Wolfram Alpha or its sort of desktop counterpart Mathematica can do much more advanced things than most dedicated scientific calculators can do, because Wolfram Alpha and Mathematica have access to a sort of underlying knowledge base. So you don't need to do, I don't know, 9.81 times 2. You can just do gravity times 2 and it will be able to look that up for you. So do calculators still have a place in technology? I think they do, at least the way things are done currently. There are still classroom environments, even if it's less so than it used to be at current time. There are still, closed examinations happening, again, even if it's a bit less than it used to. And I just think it's also just down to personal preference. I personally enjoy using a purpose-built device like a calculator. It's got, dedicated key matrix. It's got, it's got a UI tailored to exactly what I'm trying to do. You don't get, you don't get Slack notifications while you're trying to do your calculations, which you might do on your phone, distracts you. This is actually one of the marketing points that TI uses on their website, alongside their TI graphing calculators, is that they are distraction free. You stay focused on what you're doing. I think that's a very heavy element of it, is outside of education, is do you want to use a dedicated calculator? Well, it's up to you. And on that note, I will leave it there. Thank you very much for watching this talk. I certainly hope it has been interesting. And if you'd like to ask me any questions about any of this or anything else even tangentially related to calculators, then feel free to join me for the Q&A right after this premiere. Thank you very much.